So today we got a John Deere 650J. Now this machine had received a serious catastrophic system failure. It was struck by lightning, and I had to basically provide a fuse link for the negative side. It had a fuse link for the positive side, but there's two parts to a circuit, negative and positive. And sure enough, the lightning strike went through the negative into the system and fried everything. Every component was fried. That day that I swapped out everything, all the cards in the MCR3 were burnt out, so I had to replace all those. So every single PC card inside here, your main board, your back plane, GPS, radio, everything fried. The only thing that didn't fry was the GX55, which was interesting. The sensor was fried. The GPS antenna was fried. So, I had all the parts on me at the time, so I was able to get them up and running. It was like $15,000. And I did not have a new sensor. I had an old sensor. So, I put the used one on, and that got him running, so he was able to do his job. But so today, I'm bringing a brand new sensor for them just to swap that out. And we have to fix their GPS antenna. Apparently, the little coupler that attaches here, the center bolt fell out and got lost, which I carry plenty of those on me, so we'll get them up and running again. And with any job that I'm on, I always inspect every single portion of the system, everything. That way, if I spot something that's common or has damage, I can repair it on the spot for them, and they won't have any downtime. So let's change that sensor, and we'll find a bolt for that GPS antenna. And with these older style brackets, sometimes, like I said, there's dirt filled all inside there, so you'll have to be prepared to clean them out. And I carry a little screwdriver, little flathead, just small enough to get in there and round them out, get those Allen heads cleaned out of the dirt. As you see, this one's completely jam-packed with dirt. Just get these two first, get those done, and then you can work on that one, because you're gonna have to stick a flathead screwdriver all in there and kick all that dirt back. You don't want to mess around and cover those back up. So get what you can and then work on the rest. Luckily, I was the one that put this on the last time, and I don't put them on super tight. That way you can get them off nice and easy. Alright, so we got those two out. Just remove the screws and the washers. There we go. Now, the fun begins. Just gotta get all that dirt back there out. Just break it up. Break it up, break it up. And you see, this is loose now, right? So you can actually shake it, vibrate it, kick some of that dirt out. Like so. Break this up, kick it to the side. Not the greatest design, but we don't really use that style anymore. And just shovel all that dirt out until you can get to that Little tiny Allen head. Alright, so sensor is out, but do you see how this bracket is, it's not on straight? Can you see that? So just loosen it up, straighten it up to the mount. The mount is actually straight. That will give you a negative reading where you don't want it. There we go, that's better. Nice and even the way it was mounted originally. Alright, so we got the new blade sensor on, and what we're going to do is just run through a full calibration on this machine, which isn't much. A few measurements. You got your antenna on the blade, so it's a quick, easy measurement. Just a few blade measurements, and antenna measurement, and sensor measurement. Enter it into the system, calibrate, and good to go. So we're going to do that now. Alright, so first things first, just jump in, get the system up and running. And it doesn't look like we have a base. See how far that base is? No base. We're going to need the base to check. They're actually running off a network, so just have to wait for this network to kick in. Waiting for a radio link. Just make sure everything is green and you have an antenna. Ah. Look at that mag mount, no antenna. It's not running off a radio, but that's interesting. This modem, make sure it's connected tight. This is where you're going to get your network signal from. And it should pop any minute now. Come on. Okay, anyway, there we go. We're getting there. Simple thing to do here is basically just go in to your blade slope, get that to 0. Alright, get that to 0. And it's flopping around a little bit. Alright, that should be good. Get that to 0 and then physically check. Make sure the blade is sitting at 0. You can do that with magnets, or you can do that off the cutting edge. Many different ways to do this. Just line it up. Cutting edge is usually not the best idea. There's no way that's 0. You see that's a 5.2? That's okay, because we just changed out the sensor. So the sensor obviously doesn't recognize 0 yet. So we'll have to physically put that to 0. Physically put the blade to 0. Once it's at 0, then we're going to basically measure up the antenna. The antenna has to be pretty much at 0 for the blade. That way you can see if the pole's bent at all, which way does it lean, because it's going to fall somewhere else. I'll show you, you'll see. Alright, blade is physically at 0. So now we just need to basically determine if this pole is straight. You can use a level. Set it midway down here, and you can see how much off it is up there. So what I usually do is just take a level or a string line and just drop it. We'll use a string line on this one. Alright, so what we got here, basically I just took the pole, go straight up, level it coming down, mark it, and you need it from the side as well. Go straight up to the center, come straight down, mark it, put your mark down here. Now we're going to need to know how far back from the cutting edge is that antenna. How far from that right corner is that antenna. So we have those marks. And I dropped the mark down here on the blade, make it easier to see and easier to take measurements. And we also have the sensor. So we have the sensor in line. We can take a snapshot from the right corner of the blade, and we'll do that now. When measuring your antenna height, you just basically go from that little lip all the way down to the cutting edge. And we are at 932. So we basically measured from the cutting edge over to this line here, and that's the center, going up to the center of the antenna. Right blade over to this mark here, which is where the antenna actually sits on the blade. As you can see, it's not center of the machine, so you have to take the measurement on the blade. That way the system knows where it is. The system also wants to know where the sensor is on the blade in relationship to the blade. So we took that. You see the arrow right there? That's where you're taking your shot from, going this way out to the cutting edge down there. And then you're just basically going to take a shot down to the surface. It's going to be about 245-ish. Once you have those measurements, all you're really going to need are those right there. And maybe the width of the track if it wants it. So we will straighten out the blade, we'll square it up with the machine, and we'll take a shot to that pin, and then we'll take a shot to that pin, and then we'll basically get the width of the tracks, and that should be all it needs. Alright, so our blade is square to the machine, and all you have to do is go off the rod to a portion back here. Make sure they're the same on both sides. If it looks funny, start taking shots from something else. You can take shots to the track, but remember the tracks will be worn out. Take shots to any part of the vehicle back there. We got framing back there. It should be equal on both sides. You can take that shot, bring it all the way back, find out what it is. We're at 616. This one looked a little funny, that's why I'm checking it. Yeah, you see, we're already at 6.2. 629. So subtract those two, and that's how much you got to move that one end, okay? Alright, so I got the blade all squared up. It looks better. So now I need to take a shot from that right corner of the blade over to each point. Roll out your tape measure, make it as square to the machine as possible. Line it up with the tip of the blade. Start taking your measurements. We just need to know, coming off of that point, you can just eyeball square this, or you can actually use a square. You're going to get really close, so that looks like 4, 6, 8. And 12.4. Subtract those two measurements and you'll get this measurement right there. As you can see, our blade is actually sitting at a 0.0. Their scale is wrong. and this says 1.7. Let's double check that for a second. I think this blade drifts, actually. Yeah, that blade has settled to like a 7 point something. It's a nice little gauge to have on your dozer. Curious to see how accurate it is, though. That's at 0, and this says negative 2.9. Anyway, let's get out of there. We finally have connection with the network. Go into the machine setup, machine file. They have 2 on here. Not sure why. They're using that one, so we're going to delete this one. And we're actually going to copy this old machine file just so we have it. USB to 3DMC to USB. Okay, so we got the old one. This looks like the one I just did not too long ago. Nope, this is actually... Why they have that set on base, I don't know. We're going to change this. We're going to add today's date, which is... What is today's date? September 13th. Alright, so 09, actually we just put 9-13-21 space. Okay, bulldozer, middle of blade, yes, not quite middle of blade, but close. MCR3, yes, yes, yes. Let's just check these numbers here. Alright, so number 1, we're talking about the 3DM square sensor, that sensor that we just replaced. So number 1, from cutting edge up to that sensor, I got 2.45, they got 2.35, so quite a difference there. Number 2, how far over from the right corner? I got 7.56, they got 7.40. The numbers are a little weird, they're off quite a bit. Number 3, how far back from the cutting edge? I got 1.32, they got 1.30. 200s is enough for me to change. 4 is to center of rotation. Just basically take the length of the blade, divide it in half, so it's 5.03. Unless they changed the blade, that was wrong. Center of rotation, measured down, I got 0.88, they got 0.93. And those 2 measurements we just took, blade to the front wheel, 4.68, number 2. Number 1, I got 7.72. So this needed calibration, measurement and calibration. Seriously. Now here's an equally important spot, that antenna. This is what's going to get you your northeast elevation. So, number 1, from cutting edge up to that antenna, I got 9.32. They got 9.31. So that's pretty close. That's pretty good. Number 2, how far over is that antenna from the right corner edge? And I got 5.745. They got 5.76. Which is really close. Number 3, cutting edge to antenna, and I got 0.43. They got 0.33. Cole might have got bent an extra tenth there. Who knows? The total width of the blade, I got 10.06. They got 10.06. That's it. That's it. Now we are ready for calibration. Alright, blade is at 0. 0.0. That's wrong. That needs to be adjusted. And it says we're at negative 4.2. So change that, 0.0, and bam, our blade is calibrated. Wonderful. We can check the main fall. Saying 1%, which looks good to me. And that's it as far as putting a new sensor on and calibrating. So we changed some numbers here. So we want to save this new file with the new name. We changed some values, so we'll save that one as well. And that's the one we want. Hit OK. And good. Why we keep losing our radio? We're green over here. No activity. Just check the data cable and the power cable. There we go. They might have a bad data cable. It's okay to unplug. Replug, pull that power cable out. If I can get it, there we go. Take the power off it. Put the power back on and see what happens. Might have just need to be reset. It's got a reset button, but taking the power off does pretty much the same thing. And we just have to sit here and wait for it to connect. We can move around and help it out. Now, one thing I like to do after doing a repair, just check the valve offsets whenever you calibrate and whenever you change measurements and everything. Just make sure the valve offsets are pretty much the same. Jack up that throttle a little bit more than halfway. Go into valve offsets. There's your valve offsets, your raise elevation, raise slope, lower slope. If you watch the blade, we'll do raise elevation. Automatics do have to be on. That's a little fast, so we'll slow that down. That looks better. Now we'll go down with it. Way too fast. Way too fast. Lower it down, lower it down, lower it down. Come back up with it. That looks good right there. You can help it out. Alright, come back down. Bump it up just a little bit. Just where it's barely moving, but moving. There we go. That looks good. Now raise slope. Ah, way too fast. Way too fast. That side's way too fast. There we go. That's looking better. That side's still too fast. That looks good right there. Bump that up a little. That looks good. That looks good. good. That looks good. Alright, so they're all set. We changed them. Hit OK. We can turn autos off. Man, we're still not connecting. Waiting for radio. What are you doing? We might have to pull the SIM card out and move it. They might need to just upgrade to a better modem. There's no activity. What we can do, we can try a restart. See if that doesn't help it out. Yeah, there we go. So that's better. Alright. Good. Alright. So let's take it for a spin. See if it works. Beautiful. That's it. That's all there is to it. MC Square system's one of the simplest systems there is, but very effective because it does have the antenna on the blade, so it's very, very awesome for fine grading and stuff like that. Put a new sensor on. We checked out the system. We fixed that bolt problem that was up there. We updated the system with new measurements and new calibration, and yeah, so this machine's ready to go to work.